So Module 14 is going to focus on data center efficiency. We're primarily going to take a look at metrics, or how do we measure efficiency. We'll also look at HVAC systems, which is where the greatest improvements in efficiency generally can come from within a data center, um, because there's lots of different pieces that we can shift around to improve the efficiency of those cooling systems. All right, so let's take a look at some of the measures and metrics. So again, efficiency metrics are going to be essential in our data center. They're going to give us an insight into the data center operations. They're going to help us also take a look at availability. We can help us look at different ways to reduce energy consumption. It's going to help us find inefficiencies in the data center, and it is going to help us to recognize the most efficient data center. So this is a tool. Again, these efficiency metrics are things that you can use in a marketing campaign or marketing trying to gain new customers, is to demonstrate some of the efficiency metrics that your data center has, right? If you're higher than the average for data centers, or you're more efficient, it's a selling point to potential customers. So some of those efficiency metrics that we're going to look at, the PUE, or power usage effectiveness, the DCIE, data center effectiveness, corporate average data center effectiveness, leadership in energy and environmental design, LEED. We'll look at PAR 4. We'll look at the ASHRAE, or the American Society of Heating, Refrigeration, and Air Conditioning Engineers, and we can look at our cooling capacity factor, our CCF. So if we use these metrics, we can compare them to other data centers out there, or other measures that non-data center related efficiency metrics are out there. And when I say that, I'm mostly thinking about LEED and ASHRAE. They're not necessarily data center, specifically data center focused. They're focused on general industry in average. All right, so the power utilization effectiveness is developed by a nonprofit. It's calculated by dividing the quantity of the power flowing into the data center with the total power consumed by the infrastructure, and it's stated as a ratio. It's easy to look at, it's easy to clarify and adapt when you're taking a look at that, and it's easy for you to compare your effectiveness versus another data center. Or if you work for a company that has multiple data centers, now you can start comparing one data center to another data center, and then try to figure out why one is more efficient than the other. All right, so the DCIE is the inverse, right? The opposite of the PUE. It's calculated by dividing the power consumed by all of the IT equipment by the total amount of power supplied. So let's just do this as an example. If your PUE was 60%, and I'm just pulling this number out of thin air, okay, that would mean that your DCIE would be 40%. So they're related in that way, that they are the inverse of the other. All right, the corporate average data center efficiency, the CADE, is going to give the actual energy effectiveness of the data center in respect to the rate of the equipment, the rate that the equipment used in server use level. It's calculated as a facility efficiency and IT asset efficiency. So how efficient is the facility itself, right? The building and all of the building systems that are inside of them, and a secondary calculation of what's the IT asset efficiency. What are the calculations based on the IT equipment that's in the facility? All right, so LEED is a green building accreditation program that's been around for quite a long time. And what they do is they look at the material types being used, where the facility is located at, water usage, interior environmental quality, and their energy efficiency at the data center. So now, if you had a LEED certification for your data center, right, that's something that is absolutely a marketing tool, because if we look at some of the negative bias against data centers, it typically focuses around their high use of water, high use of electricity, those kinds of things. So, and if we have something that lends itself towards good environmental and energy design, that's helpful in our marketing of our facility. All right, par 4, it tells us was created by PowerAssure, which is a data center software provider. It's going to be it's tested by Underwriters Laboratories, or UL, so that it's third party certifies it, which then gives us a standard for the performance of the power on the power consumption that we look at. So par 4 is going to go in and it's going to look at idle power, peak power, per watt transactions, and total power utilization. So this is going to give us a good look at the way that we're consuming power inside of the facility in our equipment. All right, ASHRAE, the American Society for Heating, Refrigeration, Air Conditioning Engineers. This is a worldwide organization that basically sets guiding principles and standards around energy efficiency of HVAC systems. Okay, this is going to tell us what the best feasible operating ranges for our equipment temperature and humidity are going to be. So again, this is another good metric that we're going to want to be aware of, and make sure that we are conforming to their best practices. All right, CCF, which is our cooling capacity factor. This is going to look at our inefficiencies in the cooling infrastructure, which will help us figure out, hey, where can we find an opportunity to become more efficient, right? When usually when we hear become more efficient, it usually equals spend less money, right? Save money as a result of becoming more efficient. All right, let's take a look at the PUE. So our power usage effectiveness, again, it shows us the calculations of these. We saw them expressed as words before. Here is the calculations in a mathematical formula representation. It's the same information, and we're just presenting it to you a little bit differently. All right, some of the variables, right? What goes into determining your PUE on your data center? It's going to be the data center design, which is going to be what's the maturity level and the design of the data center facility. What is the rate of power use at the data center? And energy efficiency, meaning how efficient are those IT devices. So again, if we think about that maturity of the data center facility, basically what that means is how old is this building, right? Typically, the more modern or the newer that a building is, it generally has better efficiency designs built into it. So again, that's going to be something that's going to impact this calculation pretty substantially. So how can we reduce that PUE value, right? We're going to evaluate it at regular intervals. Now, whether that's monthly, quarterly, twice a year, once a year, is going to be up to the data center operator. So why would they want to calculate that? They want to calculate it to look at, have the efficiency improvements that we've tried to implement actually improved our energy efficiency? Has it helped us to reduce the amount of power that we are consuming to support the infrastructure? All right, so we know that there are 3 elements that are associated with PUE and airflow management. All right, when you see airflow management, the first thing that should pop into your head is cooling, right? I'm trying to cool the systems and the air in the facility. All right, so with that PUE, separating our warm air mass from the supplied cold air mass, how do we keep them from mixing so that they're more effective? What's that volume of air inflow management, right? How are we handling the amount of air that we're bringing into the facility, and what's the temperature of that airflow? All right, so if we look at some of the benefits that we might see with our PUE and airflow, it tells us the benefits are that we can do the calculations over a big time period. It can give us a lot of information about energy efficiency, and it's relatively eco-friendly. And again, they tell us, hey, this is a marketing tool, of course. Some of the limitations, inadequacy of the power distribution network and surges can skew the data a little bit. And it tells us that the precise IT load value has to be used for calculating the PUE and not what the rated power capacity of the equipment is. So we might look at the label, which is the rated power capacity, but that might not actually be what the real load is for that. So it can be a little bit more complicated to get a high quality value when doing that calculation. All right, so here's where the big efficiency gains and losses can be, is with your HVAC. So HVAC is going to regulate our indoor temperature, our indoor humidity, and what the volume of air is. So that's one thing we sometimes don't think about, is that we're in an enclosed space and we're consuming oxygen. We need to replenish that supply with some outdoor air at some point. So every facility is going to have some kind of HVAC system. It's going to give us the proper amount of ventilation, maintain the temperature, that kind of thing. So it tells us that, hey, depending on our data center requirements, we may have a mechanical room that houses HVAC equipment. We're most likely going to have an air handling unit, an AHU, that's going to use to humidify or dehumidify, ventilate, right, bring air in and out. It's going to filter the air that comes in, and we're likely going to have a dedicated room for controlling the HVAC system. All right, so the efficiency is going to be related to how well can we cool this equipment, right? How does this thing work to take that hot air and move it to the outside? And again, when we're running these things, it's going to consume a significant amount of electrical energy. All right, so for this thing to be effective, we're going to have our input segregated into two parts. Okay, so we're basically going to meter the IT equipment energy use and the HVAC energy use. We don't really want to combine them, because then it's hard to tell if we're being effective based on what we're doing to the IT equipment or based on what we're doing to the HVAC equipment. So if we measure that or meter that through two different systems, now we can look at two different measurements of energy use. And what they want to do is they want to look at how many kilowatt hours per year do we burn using our IT equipment and how much using HVAC equipment. All right, so our airflow efficiency is going to remove, it says here, remove thermal stress. Yes, it's going to take heat from inside and put it outside and bring cooler air inside. So to calculate that, we're going to look at how much power, how many watts do we use for our fans versus how many cubic feet per minute of air can we push through. Right? How much energy does it take to move a specific amount of air? And that's what we're looking at for our airflow efficiency measurement. All right, it's also important that we run that HVAC system efficiently, and it tells us that here that the HVAC system is going to account for almost 40% of the data center's total power consumption. So just to keep the temperature, humidity, and airflow maintained is 40% of the data center's total power consumption. So that's almost on par with what your IT equipment's going to use as well. So it tells us there's three different ways we can measure and monitor the power use efficiency for the HVAC system. We can look at it from the season energy efficiency ratio this year, our energy efficient ratio, and our heating seasonal performance factor. All right, so it tells us that there are 12 steps for achieving an energy efficient HVAC, and I'm going to go through these relatively quickly because all of this material is in the text, but I just want to point them out as indicators that this is something you should be looking at. All right, so one way we can improve efficiency is we can backfit or retrofit an old system. Okay, if it's still in good condition, we can replace some components with more energy efficient components like condenser fans or compressors, that kind of thing. The other thing we can do is we can insulate the space, right? So if we can keep more of that cold air in the ductwork, we can do a better job of moving that cooler air through the facility. All right, a programmable temperature control system is a must, right? We need this so that it can adjust the indoor temperature based on what the outside temperature looks like, and we can allow that to happen automatically without user intervention. We can also regulate the airflow so that the HVAC burden can be reduced, right? As we get dust and debris and other things that can start to block our airflow going through our cooling systems outside, that can make it more inefficient. All right, performing regular maintenance. Again, this is something we want to keep the system in good condition. We want to change the air filters regularly as they start to fill with debris. It takes more power to pull the air through that air filter. All right, we can install fans. Right, it tells us that not every heat source requires AC to cool it off. We could just use a fan in there to move air through. Again, most racks, for example, are going to have fans, but sometimes they have locations where you can add additional fans, or you can buy them with even more fans in them to move more of that air out. We can put our outdoor units in shaded locations so that it can reduce the amount of power that it takes, right? If it's right out in the sun, we all know this. You put something out in the sun, it's going to get a lot hotter than if it's sitting in the shade. So if we can place our equipment in a shaded location, it should use less energy to cool things down. All right, raised floor plenums. We've talked about this before. This is a place where we can have airflow go through. So it tells us that if it's overly full, it can restrict airflow, making it more difficult to cool. So we want to make sure that we lay out our cables and everything that's under there properly. All right, we want to stop recirculation in cold aisle and hot aisle containment. So we want to make sure that with our cold aisle, we're bringing that cold air in the cold aisle, having it go through the computer system, and then the hot air gets recirculated out the back. We want to make sure that we have obstructions taken out of the way. This is a good picture, right? It shows a lot of like boxes, cables in the way. We want to make sure that we are maintaining our layouts to make this the most efficient that we can. Another thing that we could do is we could use a computer room AC unit, or CRAC. We can put this, it tells us to put it perpendicular to the rows, which means that we're going to push the cooler air through that cold aisle and not mix it with the hot air coming out our warm aisle or hot aisle. And we can be more energy efficient by designing in and buying and using more efficient equipment right from the beginning. So we want to consider the Energy Star ratings before we invest in those systems. We've also got the opportunity to use portable and permanently installed efficiency measurement equipment. All right, so in order to determine what we're doing, we have to monitor the consumption of power on these devices. So we can either use portable systems or permanent sensors that we want to place within our facility. So this is an example here of portable instrumentation, right? You can carry it through the data center. We can check temperature sensors, airflow readings, and that kind of thing with some of these different handheld units. Or we could also have permanent instrumentation that's installed and fixed in place for monitoring things. All right, so to go through and effectively monitor, we need to have a good strategy. We need to decide what devices we're going to use. We need to determine where we're going to put those devices, and we need to implement it and put them in place, and then we need to actually track and monitor them. And then, over time, we're going to explore other instrumentation options or other opportunities for us to find improvements in our efficiency of power usage. That gets us to the end of Module 14.